Still capital budgeting. Under uncertainty, I mean, under uncertainty, those who are around, you will remember, under uncertainty. And we did the first part, which was a probability-based approach. But today, we're trying to conclude the second part, which is non-probability methods. Non-probability methods of evaluating a project under risk and uncertainty. We're going to take them one by one. The first one is payback period. Payback period with limits. That means there is a limit here. We may say our payback period within 4 years. If the money is not paid back, we can invest. Equally. Within 10 years, if it's not paid back, we can invest. Within 2 years, if the money or our cost of project is not back, in 3 years, we cannot invest in such project. But the number one we did before was payback period, discounted period. But there was no limits. There was no limits. We do not have a target. Our own is that's payback, we can invest. Whether it take many years to pay back, we invest. But now we want to look at there is what limits. That's the first one we're going to look at. The second one is a risk adjusted discount rate. In this way, this method means that our cost of capital or what have you, or the discount rate or the opportunity cost has to be determined using two interest rates. One is called the risk-free, which we know before, plus the premium risk or risk premium. We'll jam the two together and be able to use it to determine whether the project is something we can invest on. And all of them, most of them is still based on our NPV approach, which I believe we all know, and that will not be so much. The next one is certainty equivalent approach. That method, for instance, this one now deals with the interest rate, deals with the rate. This one deals with the cash flow. The cash flow, something needs to be done to the cash flow in a form of reducing it so that we can determine. And the last one, which I believe we should be able to do, sensitivity analysis. I hope this my sensitivity not long too much. Is it correct? The sensitivity. Okay, these are too much. I see where the mark around the work out. Sensitivity analysis. So those are the methods we're going to be looking at. And with that, we have concluded capital budgeting under uncertainty. Maybe later we'll be looking at capital rationing, cost of capital, leverage, and so on. That will be as we come back in the new year again, by His grace. So, but for now, let's see how it works. I hope you are those of us online. Are you saying it? Hello? Are they there?
Yes, we are there. We can see it.
Good. You have seen it.
So we're taking the first one. We'll go write question on the board because I don't dictating it. I don't think you can get that easily. But let's write on the board and see the first question and see how we can take the thing. And I believe we all understand. It's not that it's going to be so difficult. Let's see the first question. The first question on pay backwards period. But for us, first question for today. Johnson Limited. Johnson Limited is planning. Don't know what they are planning, but they are planning. It's planning to spend 2.4 million. 2.4 million on a project. That is expected to last for 10 years. The project is expected to generate annual cash flows of 600,000 naira. 600,000 naira. The firm's cost of capital. The firm's cost of capital is 15%. 15%. And the company requires all capital projects to have achieved payback in discounted cash flow. Terms by the end of 5 years. Otherwise, the project, you can determine what you want at a particular time. That does not mean it's not set that it won't come again. Otherwise, the project will not. Otherwise, the project will not be undertaken. Project will not be undertaken. Advise the company. Advise the company on on this project.
Can you hear me now?
Those of us online, can you hear me?
Yes, sir, we can hear you very clearly.
Yes, sir, we can. Thank you.
Thank you. So the second question is already in your WhatsApp group. But don't worry now. When we get to second question, we don't need to copy again. So at least that one is there. I just screenshot it now and sent it so that we will not copy. We are covering. We want to cover. How to okay, sir.
Cost of capital is 15%. Am I correct? Good. And this project every year 600,000. I mean, for 10 years.
I hope you don't expect us to go this way. Solution.
Don't expect us to waste time. This the year 0, 1 to 10. I hope you agree with this. 1 to 10. We cannot be doing year 1, 600,000, year 2, 600,000. You understand? So from year 1 to 10, we do it every year 600,000. And we apply our normal formula of present value annuity. Have you forgotten? Or in case you have forgotten, we'll remind you. No problem. There is hope. The project cost is how much? 2 million, Abi. 2.4, Abi. There's a minus, Abi. So our discount factor at what? At 15%. Our present value, which I believe is not a problem. We all know what is present value very well. Good. So everything is taken care of. This is one, Abi. That is why I have to continue with this topic that has to do with NPV. So that when I finish everything about NPV, we now move to cost of capital that does not have anything to do with NPV, leverage that has nothing to do with NPV. So we know NPV matter. It's gone. I need to remember that. So I hope you have not forgotten what you do very soon. What? Yes. No, I'm coming. I know. I will try my best. Abi? Year 1. If this is 0, Abi? 0. Everything will be 1, Abi? You know, year 1, we divide it again by what? 1.15, Abi? On 2 lines. Assuming this thing now was 1 to 10, and the cash flow was different every year, but because this is from 1 to what? We now remember our formula: 1 minus 1 plus r raised to the minus n. Remember this formula? Remember? Okay, but in case they have forgotten so soon, I don't know. Let's see what we can do. If they have forgotten so soon, remember what we are doing here is NPV. We're using net present value here, Abi? That's what we're doing here. Fine. Now, if you have not forgotten, we have summation. Abi? Capital 90 over 1 plus r raised to power t. T starting from 1 to what? There, Abi? You remember that this is the normal way we used to apply it. So that when is the C, which means this will be equal to CF into 1 minus 1 plus R. Check their notes. Don't know why we are forgetting. Abi? Is in their notes. This one is present value, ordinary annuity. Have they forgotten annuity? Or if in case you get to exam and this becomes a problem, no worries, take your time. Here, one more time, I'm going to say answer. No problem. But instead of that, we can do from 1 to 10. because we know this formula. So we just put minus 10. Our data is value. So what we're going to do here, walk in circle, walk inside this corner. Okay, what is here? It's to say 1 minus 1 plus 15% is 4.15, Abi. Raised to power minus what? All over 0. Somebody help me. Press that calculator. Let's believe from year 1. I'll show you now so that I can understand. So that I know why we call this, and let's be convinced that we are right. Let's say 7. Okay, 8. Watch. Let me clear you now. Watch. Hello, help me. This year what? 0. I mean year 1, I mean. This 1, I mean year 0, go 1, I mean. So, this down is 1.15. Press your calculator. Divide 1 by 1.15. 10. Just tell me. 0.866, Abi. Let's do like if your calculator can help so that you don't buy me alone. See now, if your calculator help me write 1 over 1.15 plus 1 over 1.15 raised to power 2. So that you get 60. So that in case you don't like this formula, you don't like it, you can't remember, and the thing is 1 to what? 10. So we do year 1. This is year 1. Year 2. Year what? 3. Continue. Year what? 4. Till year what? Oh yeah, now when you add it together, you must get this. So let's see. Somebody do something. I think you can run this fast. Try so that if you can't remember present value annuity to make it faster in exam, you can as well use year 1, year 2, year 3, year 4. Year 4 till year 10. And your calculator can run this at the same time. That means if you are using a calculator, you can say 1. Let me just put it. For everything is 1, 1, 1. Your calculator can have 1.1 plus 1.1 raised to power minus 1, 1.5. 15, sorry, 15. So your calculator can run it as it is now. 1.15 raised to power minus 1 plus 1.15 raised to power minus 2 plus 1.15 raised to power minus 3. Like that. Run it to 10 and press equal sign. Let's see what you're getting. That's another way of getting the. Okay, you like this method? There's no but so that there will be minus something on top.
So let me see whether you are doing it very well. Those of us online. Those of us online, are you following?
Yes, we are following.
But that method on the board remains the best, faster, because getting to 10 is a lot of work. But in case what matters at the end of the day, you got answer. Yes.
This one. There's a formula to run from 1 to 10. Yes, this one. You know, we have done that before now. We say, this inverse, Andy. This inverse. You press a calculator 1.15. Raise to the power of minus 1. Because it's that inverse. When you remember this, you will get there. Because let's assume it was raised to power minus 100. What will you finish? So that's why you must do this. Present value annuity. This is a long journey. I have done it. Yes. No. This present value ordinary annuity. Present value ordinary annuity. As a formula. So that formula helps you to compare when it is from 1 to 10. Please.
Is it the discount factor? This formula 1 minus 1 plus 0.5
Our discount factor rate is 50%.
But the present value does it? Is it now when you multiply this discount value?
And when you multiply this by this, you get present value.
Yeah. So that's where it comes.
No, you know, they computed annuity. Annuity. Because in this case, our present value or cash flow is constant for 10 years. I mean, the same thing throughout. That's what annuity means. Because annuity means receipt of payment, series of payment, equal payment at a particular period of time. Okay? So that's why this formula helps in combining all these and things.
So what I'm saying is that this is present value ordinary.
No, this one is not involved. It's only this
You
alone.
don't need it.
There is a present value. So our cash flow is still where it is. Now, okay? Good. Another question? I hope this settled. We don't need to go over this again. We use long method to get the same answer, but short method is better. I'm just trying with this. I saw the answer. Or you want me to give you all again? I wonder how much you are going to go. So this one will what? Final.
Hello, sir.
Okay, let's put it up bracket. Hello, those of us on any question?
Hello, yes, sir. Hello, sir.
Hello? I can hear you.
Yes, sir. I said, why is it raised by minus 10? That's 10 years.
Why 10 years?
Why is it raised
You
by
said-
minus? Why the minus? Why is it
No,
minus
the
10?
formula.
Why?
Hello. The formula has minus n, and we can query the proving now. The proving is in order and it's working. So there is always minus n. Take note for present value annuity. It has been proved. We have done that before. If you check your notes, you will still see it. But in case you don't see, that's not important now. What's important is that the formula has minus n. And our n here is 10. Is it clear? Hello? Okay. Now, somebody help me multiply 600,000 times 5 points. So, if you add this, somebody help me. 3 million minus, that is minus, Abi. This is minus. This is minus, Abi. You know that this MPV, present value minus what cost of cost actually, Abi, will give us MPV. Oh, yeah. 611. 287. Good. Is it positive or negative? Ordinarily, a project like this. Positive. But remember, we're talking about discounted payback period. Abi? The payback period said 5 years, the money should come back. So, we want to check whether it's true, whether it will come back. With this is the same thing. This 10 years, so we're talking about limited payback period. According to the question said that if the cost of capital is not paid back in 5 years, we should do what? No. So let's find out. Still the same question? 0. How many years? That in 5 years' time, our NPV must be positive, or even if it's positive, but we must check and know whether I can pay back. Here is cash flow. 24,000. Here's 600,000. This is a discount factor. This is 1. I hope they have not forgotten now. It's 1 minus 1 plus 0.15. This is 5 minus 5, I mean. This is 5 now. 0.15. This is this is what I'm going to use now. You can now press the calculator. Let's see what it will be. This is our present value on the naira. This is already 2400000. That's 2,400,000. For 5 years, because the first is that this project was paid back in 5 years.
And this is 3 point, Abby. That's good. 3.352, Abby.
Everyone join. Yes. Okay, two. So what do you have? This times this, what do you have?
Times 600,000. Somebody multiply.
2 million.
2 million.
011.
011.
3K. 2 million. 011. 2.
320.
Are you sure it's 3?
Yes.
Or 29.
3.3522.
Okay, let me confirm it. Okay, we're using 3.3522 a day times 600,000.
Okay, it's 320. Okay. 11320. Okay, somebody subtract. Is it positive or negative? Good. So what do we have? Minus 386. Good. Ordinarily, you can see clearly that they cannot even pay. That means in 5 years, they can't pay back. Because there's a limit now. It's expected that we should do what? Reject this kind of work project.
But we can do a rough estimate. Automatically, it's very clear.
Reject the what? Project. It shows that the business is risky and what? Unacceptable. Reject the project because it is what? Risky and unacceptable. So, but I want to find the question, which is not part of the question anyway, but sometimes it could be. I want to find out how many years actually will this project pay back. You can use this one to find out how many years it will pay back. This one can help us to know how many years. Is that okay? Copy, that one is part of it. That one is just an additional something. Over 7. 6 plus or something. But there's a way to find out. You have the formula to find out. It's on the board already. Any question? Let not copy. Everybody. Those of us online, any question? Please do. Okay, moment. Those of us online, can we clean or any questions?
No question.
It has minus 9. I believe they are copy. At least I can think now power no matter how the thing is. So we can easily find out because as far as the project is concerned, the annuity is 600,000. Am I correct? Yes. The annuity is 600,000. The present value is the cost of the project. Am I correct? The present value is the cost of the project. So the present value is 2,400,000 equal to annuity 600,000 into 1 plus 0.15 all raised to power minus n all over r, which is 0.15. What are we looking for now? N. And I've taught you how to look for n sometime. I remember what you did. So in a simple logic, 2, 4, 0, 0, 0, 0, 0. Divided by what? 600,000. Want to find out the real how many years will this project pay back? He has failed to pay back in 5 years. But want to know how many. Because the question could go for it and say, how many years will this project pay back? And this is the formula to use. Present value, ordinary. And the present is that cash flow that was constant throughout 10 years. I mean, but now we want to look at how many years to be. Then that cost of the project is your present value annuity. Is that okay? So ordinary annuity in general. So here it's going to be 1 minus 1.15 all raised to power what? N all over 0.1. Somebody help us with this? Divide. Divide that. I hope you have something. 4. 0.6. Or 1 point something. Okay.
Excuse me, sir. I think the 1.5 should be raised to power minus n, not n.
Hello?
Sir, in what you wrote on the board, sir, the
Sir?
2,000, in what you wrote on the board, the 2.4 million divided by 600,000 equals to 1 minus 1.5 raised to power minus n, not n, sir.
You said raised to power minus n.
1 minus bracket 1.5 raised to power minus n, not n, because you wrote raised to power n on the board, sir. I think it should be raised to power minus n. Yes, sir.
God forbid. It can't be ordinary n. No, present value ordinary annuity is minus raised to minus n. Go and check your formula. We are proving
Sir, I said you wrote.
around that time.
Sir, what I'm saying is that I think you wrote n, not minus n on the board, sir.
Oh, you are the one not seeing. Okay. Oh,
better. I was wondering. And the upper one is minus n. I was wondering whether I think it should be n.
Okay, sir.
better. Thank you for noting that. I thought you were changing our profession.
No, sir.
Yeah, better. So it's the upper one is minus n. So that should also be minus n.
Somebody divide that for us. I hope you're 4. Are you sure?
Yes.
All right.
Okay, 4 times 0 for more.
Let's say it's 4. Okay. 4 equal to 1. All raised to power minus n a bit. Like this. We cross multiply. I hope they are there. I hope you understand that. This one now cross multiply. This one 1 times 6. A bit. Very simple. Now what are the 10? This times 6. We have this. So open what? 6. Good. Equal to 1 minus 1.15 all raised to power minus n. Collection of lighter. Abi? We have like this 1.15 all raised to power minus n equal to 1 minus 0.6. Agree? Collection of lighters.
Yes.
It's all like this. Just like this. What is here came to this side. What is went to this side. That's what they call collection of light cards. So here's 0.6, have it? So 1 now minus 0.6. And this was minus. You come to this side, you come plus, have it? It's still simple inflation. Have it? Can we continue? Look at it very well. And not be... What is this? What is this? So minus coming to this, our limit. Our bracket, nothing happened to bracket. It's not what we're carrying. We're not changing this. This one, because it's causing sign of what? Equality. It's changing from minus to plus. What is on top hasn't changed. So this one is ordinary positive. You will go to what?
When you are moving those sides, those some of us are not mathematically inclined.
No, they are getting
So there, leave. And they are moving, you want to tell us.
No, I
like
told
this one
them.
now. They did not put the positive there. I did not tell us, no,
Okay, every number is positive, irrespective of how big or small a number is.
Exactly.
You are working. You are doing well. Ayana. Is it clear now? Yes. Even we can remove the bracket episode, but we are trying to cover the two so that somebody will not think the one is separate. Is it clear? Okay. It's trying to be clear. Let me see. Okay, I can put this 1.15 all raised to power minus n. Abi? 0.4, Abi? Good. There's no way we can bring that n down except we apply logarithms. That's what you don't like. But they say we should do it. It's not me. When you are applying for the program, you don't see this kind of thing. I don't tell them. Let's say you want to do business. And that was, sometimes one would think they are going away from us. Okay? We'll try moving to this corner. Apply logarithm to both sides. It will be log. Okay. It will be log 1.15 raised to power minus n equal to log 0.4. That is applying logarithm to both sides. Apply logarithm. So I put that is natural log. Anyone you like, both of them will still work. Logarithm to base 1 to both sides. I mean, apply it to both sides. To both sides of the equation. That's what we apply log here. Apply log there. And for one indication, this one has minus n on top, I mean. So it's going to be minus n log 1.15 equal to log 0.4. And this will be minus n equal to log 0.4 all over log 1.14. And somebody can do some division there without stress. Are we there? Where? No, check this one and the other one. No, the other one. Or is it this one with n?
Maybe you just.
No, is it this one that has n or this point? Is it at this point? No, wait, don't crack. Mass should be the crack. Is it at this point? Fine. There's a law in logarithm. The law says that logarithm of n raised to the power of p. The law says that it should be p log what? That's what we're following. Yes. Those who came before us created media sources. People like Pythagoras, they tried. Pythagoras, Newton, these are our great grandfathers. They said we should follow the law. Who are we? I want to disrespect any people? No, don't. So the power is off to bring it down. When you do it like this, they say you're mathematics. When you don't know who, when you do like that. This power is here. So I divide this. You get 1 point something, 6 point something.
Why is it 6.5?
And okay. This n, Abby, the coefficient of this minus n is this. Divide both sides by that coefficient.
Okay, by the coefficient of that.
Yes. Or better still, that coefficient must be our denominator always. So minus n now will be this one first, all over that coefficient. That's always been the rule. You're welcome.
Minus 6.
Minus 6.55. Minus 6.5.
6.5 years.
No, I want to.
Minus 6.5.
5 what?
5.
Good. So approximately n is 6.6, I mean?
Yes.
So that means it is obvious that this payback period cannot pay back in 5 years. And it is clear that we should return the project. It does not fall within the limits. Because what the limit of 5 years, it does not fall. So that's all about payback period. With what? Limits. The ones we have been doing, there was no limit. This one has. So we are moving on to the next agenda, which is risk adjusted discounted. Yes, ma'am. Just press your log, press log 0.4, divide log 1.14. This thing will come out. It will not come out like that. You don't press it. Is it clear now? So please put it down. Those of us online, are we following?
Yes,
Hello?
sir. I am following.
That's doing well. Good, 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 good. So we are moving. Those of us online, can I?
Yes, you can.
Good, good, good. So we're looking at the second method. Second method of non-probability approach or non-probability method of assessing a risky business or assessing under uncertainty. Want to look at that? So, first of all, okay, we're looking at number 2. Let me write it down. Risks adjusted. Risk adjusted discounts rates. That's the method we're looking at now. In this method, that is the question you are seeing on the board. Right. But for us to talk about risk adjusted, it is a combination of the risk free and the risk premium. But first of all, we have here 0, 1, 2, 3, and 1, 4. And this is the cash flow. I hope it's 150,000. Good. Year 1 is what? 72,000. Year 2, 63,000. Year 4, or year 3. Sorry, year 3. 30. Okay. Year 4, 27,000. Good. Now the discount factor we are using now is the risk-free. We are looking at the risk what? Free, Abby? Risk-free rate. At how many? What's that risk-free rate? 12%, Abby? Good. So that's what we're using. 12%. 12%. First of all, before we talk about the risk adjusting. Now, this is our present value. Present value. So this is 1, and this is 150,000. Hello. Look up. This is 1 whole number, B. Divided by 1.12, Abby. Remember? Hello. Can you see this? Our R is 12%, Abby. And that is 1.12, Abby. So the year 0 is 1. To get year 1 is to divide this 1 by 1.12. I hope we did that some few minutes ago. Good. Well, divide this 1 by 1.12. I hope you understand we got that. Are we? Those of us on side, any question? So what do you have? 0? 8, 9, 2, 8, Abby. Good. Divide this one by 1.12. Notice year 1. Divide year 1 by 1.12 to get year 3 or year 2. 0.79719. It's too much. So possible. You don't want it. So this one I got now, divide it again by 1.12 so that we can move to third year. 0.64 what?
0.6655.
Wow.
0.6646.
0.711.
Or 8, Abby? No, this one.
0.7118.
Okay, 7118. Like this, Abby?
No.
Okay, try it again.
Press again. Those are saying no. You better press calculator better way. 6355. I'm coming. This is 4.7972, Abby. Divided by 1.12. What do you have?
It's as easy as that. Please check.
0.6555. Simple. That is noted. I hope you have seen how we did this one. Hello. You see how we did this one? See formula 1 over this, Abby. It only is 1.12. So it will be 1 point raised to power 0, Abby, or year 0, Abby, and we'll go 1. Denominator is 1 constant, Abby. Now, if this is 1, to get the next year, will be to divide 1.12. Because raised to power 1. That is. You get the next one divided by the denominator, 1.12 like that. Instead of wasting your time using the other method. Of starting over 1 over 1.12 raised to power 1 over 1 raised to power 2. That's the number. No. This is the formula that we are using. Because the cash flow is not the same. If it were the same, we would have used the other one to make things faster. Is it clear now?
For year 1, the discount factor is 0.8929. 0.8929.
Okay, is it 29?
Yes.
Let's see.
Divided by 1.25.
Okay, 8929. You are correct. 9. There's other ones I know that. Is it clear? So we multiply. I hope it's 150,000, yes. So this times this. Press calculator. So 2,000 times 8929.
64289.
64289. And 9, very good. 9, approximately. Then the other one, 0.7972 times 63,000. I hope you have 50,000.
5224. 24. Yes, sir.
224. Good. Oh, the next one is what? 21,354. The last one. The last one, 17,159, Abby. Good. Add everything together. Our MPV is what? Add everything together. The PV is a minus. Minus plus this, plus this, plus this, plus this. What do we have? $3,025. Is it possible or negative? Good. Remember, with the risk free, this is risk free, Abby. With this risk free, we get a positive entry. But we're looking at the risk rates adjusted, discount, rates is equal to
Please, why is the PV? That's 150,000. Why is it minus?
That what?
I said, why is the 150,000? Why is it minus?
That is our cash outflow. That is the cost of the project. The cost of project is minus because it represents cash outflow. Why the other ones are plus? Because it represents cash inflow. In a simple language, from year 1 to year 4 are all receipts, while year 0 is payment. Is it clear? And payment are always a negative. Is it clear? Hello, are you there? Okay.
It's clear, sir.
As you not talk and they want that. So this is a risk-free rate plus risk premium.
That question has two rates, Abi.
One is risk-free rate, and one is risk what? Premium.
Addition of the two
Gives us risk adjusted discount rate.
Now, it is that rate we are going to use to know whether we can invest in this project or not, where the project is risky or not. If our NPV is negative, it shows that we can't invest because the project is risky and therefore is unacceptable. Is that okay now?
But when we are using risk-free, our NPV was positive.
We can invest because it's risk-free. It's like a treasury bill, it's risky.
But now that we are using risk adjusted,
that means that our interest rate has been adjusted considering so many factors. So this is risk premium. And that means there is what? 12% of it. Is it 5% that is there? Check.
Yes.
Good. So we're going to do the same thing we have done all over again.
we just adjust something on the board.
Are you following? And just change our 12% to 17% to know whether we can still invest in this business with risk adjusted discount rates. If our NPV is negative, we cannot invest because the project is risky and therefore we don't accept it. Okay? They gave us two risks, two rates. One is risk-free. That is a kind of comparing with treasury bills. But treasury bills are the security issued by federal government. Is that okay? So the risk is free. As far as federal government still at 6, there's no shaking with that kind of rates. Fine. There is a risk premium that is available. When you add a risk premium, that is premium is profit. That means if you invest, the profit that will come out of it normally is risky. Is that okay? That is why. But we are giving two rates. Risk premium rate. Risk premium rate is 5%. And the risk free is 12%. When you add the two together, it's now known as risk adjusted discount rate, which is the new rate we're going to use to find out where the project is good for us to invest. Or now that we have done that, this all over again with 17 and no more 12, we'll just change the thing. All this place, we just change with all these ones. That's all. So here is now 17%. So we're not talking about risk what? Adjusted discount rate. Now we're talking about 17%. Oh yeah, somebody help us. Please. 0.8547. The next divide by 1.17. 0.7305. Next. Divide again by 0.6244. Divide again by 1.17. 0.53. 7. 7. No, 0.5337. Okay, 337. Good. Now we multiply the same way we have been doing. 72,000 times our discount factor, as usual. Oh yeah, what is happening? Okay, 61538.4. It's not to 5, so we leave that. This one 63,000 times the discount factor. What do you have? 46,022. Next. 30,000 times the other one. 18,732. Finally, that's 27,000 times this. 1,000. Are you sure it's 1,000? Okay, 14391. Good. I add everything for us. Remember this minus? Are you sure? Okay. 43 now what? Oh. Calculation. Wait. 14. 410, yes. 410, yes, correct. You have to approximate, except you want us to visit the problem, which is not right. So what's the answer here? Add all this. This is a minus, so minus plus this, plus this, plus this, plus this. What do you have? Oh yeah. What's the result? My outset, out with the board. So check your WhatsApp group. The second question, but it's not the method. It's there. I'm going to work on that now. Yes, Adegoke. They has part 1, part 2 there, isn't it? Yeah. There is Adegoke that gave us the cash flow. Then you go down again, you now see the certainty or the alpha, as the case may be. The alpha and the interest rate. So it's not something that is so difficult. That we even use I can say how to make it faster.
Hello, sir. Hello, sir. Before you go on, sir. Hello, yes. Sir. Yes, my question.
Hello?
Yes, my question is this. I want you to please make this risk premium rate to make it more practical so that one can still understand what exactly it is, or more explanation as you can understand. That is one. Okay. Then the second one.
Go ahead.
And the second one has to do with this cash flow under the project evaluation. Do we mean the cash flow? The EBIT, that is any before interest and tax, or any before interest, tax and depreciation and amortization?
Okay, it all depends whether it is cash flow or net profit before tax or interest. Whatsoever they have given you in exam, let's assume they are giving you till a net profit and you remove depreciation, remove tax, remove whatsoever it is. Whatsoever you get is regarded as your cash flow. Is that okay?
Okay.
That one is settled. Then that
but before you go,
yes.
Before you go for that, sir, in evaluating a project,
Yes.
like a situation whereby my company decided, okay, they want to take a loan, then they want to evaluate whether it is, I mean, they'll be able to pay it over a period of time that the department should advise. So on a situation like this, should we now consider the any before interest and tax or any before depreciation and amortization?
Normally, when it comes to depreciation, you have depreciation has to be involved, tax has to be involved, but it's not every time, but in practical life, there should be tax. But you should consider after tax, not amortization. That's not a part of a trading profit and loss account stuff. So your result is after tax. That is your net cash flow.
But if we use the one of after tax, what of the value? I mean, discounting it to get the PVN, to get the present value rather.
No. When you get the net cash flow you have gotten, whether it is before tax or after tax, all of them are still cash flow. So if there is tax involved, fine. But we know that every corporation wants to pay tax. So there must be after tax, which will give us the real cash flow for us to work on. You get your present value as usual before you can now know whether it is a positive NPV or negative. Remember what we're using here is net present value to evaluate all this.
Okay, sir. Thank you, sir.
Clear?
Then the risk premium.
We are simply talking about those interest rate that does not involve risks, like treasury bill. I hope you know treasury bill being issued by federal government.
Yes, sir. Yes, sir.
And that is risk-free. So we're looking at risk-free where there is no risks involved. There could be other factors involved, but there's no risks. So with that, and we have an NPV of positive, we can invest. But from what we have written on the board, risk adjusted. We want to adjust that particular risk-free to something else and know whether we still have a positive NPV. When we discover that we have a negative NPV, it shows that that project is what? Risky. And otherwise, we shouldn't invest in that kind of project. Is it clear?
Yes, sir. Thank you so much, sir.
You're welcome. So we're moving on to certainty equivalent approach or method. Unlike the one we just finished now, we adjusted the interest rate or the discount rate. For this one, we're going to adjust the cash flow. This is risk adjusted discount rate, which affected our discount factor. But now we're not after a discount factor. We want to adjust the cash flow by applying what we call certainty equivalent rate or alpha, as the case may be. From that question, you copy. But before that question, let's just give you the formula for us to use it. Number 3 now, certainty. Certainty equivalent approach or method. So in this method, this particular method is represented with what? The symbol alpha. You saw alpha in that in copy, David. So our NPV now will be summation alpha at time t, our cash flow at time t, all over 1 plus risk-free rate, which we know, raised to the power of t starting from 1 till n, minus our cash flow. That means minus our cash flow at time 0. I hope you know our cash flow at time 0 is always minus, okay? Which is the cash outflow. So we can do it like this. Or we follow other approaches like our tabular form. We're using tabular form since, whichever one. Let's take go to our tabular form. Like that. Which one?
Something like zero.
This A raised to power 0 at this of speed. And this one, A here is a cash flow, right?
So it's minus A.
A now minus A0 means cash flow at time 0. We all know our cash flow at time 0, which is the minus, which is our cost of the project, I think.
Sorry, cash flow
At time 0.
at times.
Year 1, and year 0. Is that okay? Yes, this risk-free rate, Abby, which we know is in the question, risk-free. That's the cost of the capital. Alpha is the certainty equivalent approach. That's the alpha. Yes, alpha at time t. The t could be 1, 2, 3, 4 like that. But we're not going to multiply the cost of project. It's already 0 already, so there's nothing there. Even the alpha you got, the alpha that was your 0 is 1. That is constant. 1 here is constant. Sorry, 1 is constant for all. So that's not a problem. 1 we're used to 1 as an alpha stuff, so that the cost of
Use your mic, sir.
Hello? Okay. Now, let's use table. It seems we like this table a lot. Let's use table. Yeah, at time 0. Okay, yeah, 1, 2, 3, 4, and 5. Abi? Is our cash flow. What's our cost of project? 675? Confirm. Are they confirming? According to that question, that's 7 million, Abi. Hello? 7 million? So that's why I put 0, 0 on top. So we don't need to bother. This is our alpha. This is our certainty equivalent approach. Certainty equivalent approach. But before that, this is 5,000 watts. What is it again? Is it your notes? I mean, what's the oh, network, Gola. Okay. 4, 5, sharp. 4, 8. 4, 2. 4, 8. 4, 2. And 3,000. You see the same thing we are doing. They gave us 0.9, Abi. 0.8, 0.6, 0.4, then 0.3. I mean, this is the certainty equivalent values. I mean, very good. Our discounts here at how many percent? 12%. That one is a 1. We have done 12% today, Abi. Can you go back to your note and call 12% for us? We have done 12% today. Don't be stressed again. 0.892. Okay, yes. 0.7972. S. 7,118.
0.6.
You see that one stop at year 4. So but let's take year 4.
0.6355.
6355. Yes. So yeah, divide this one now by 1.12. It's 12% for us to get year 4. The former one did not get to year 4, right? Oh yeah, now divide this year 4 by 1.12 so that we can get that particular value. Are they following? Oh yeah, divide this year 4 by 1.12 to give us year 5. 0.5674. Any questions? So we are going to add everything together. Oh, sorry, not yet. As a present value, are they? Good. See now, everything. Everything. This A, call this one B, call this one C. This will be A times B times C. Is it okay by us? The last one is what? 5675. It's not correct? Okay. Calculator. Let's find out. Uh, 0.6355 divided by 1.12. It's correct, Abby? Okay. Somebody multiply. I hope you are getting it. A, B, C. Already, this is just an inclusion, Abby. Yeah. This is the only thing that was included. And this particular version is to reduce cash flow. Is to decrease it. This certainty equivalent factor or method is to reduce, is to attack cash flow. When the risk adjusted is to attack the interest rate, I mean, fine. So you need to understand what they are targeted at. This is just to reduce the cash flow as a result of risk. Right. So multiply now. This is 17500. This 4219 times this, so 3 things, Abby. Yeah, 4219. Oh yeah.
That's 4 million, right?
Yes, there's already thousands of them. So yeah. 2870. 2870. Next. 4,800 times that? 2050. Next. Therefore, somebody 1068. Okay. Are you sure? 4,002 times 0.4.
Yeah, 0.4 is good.
Okay. It says
1068.
1068. Okay. 3,000. 900. Okay. So we add everything together. Okay. Is it 900?
It's what?
It's 511.
Oh.
0.3
My people.
times 3,000.
It should be 500.
511.
Thank you. 511. 511. Okay? Yeah, so we can add everything together. Those of us online, I hope you are following. So calculate, let's know whether we have an NPV of negative or positive. If it's positive, we can invest, Abby. If it's negative, we cannot invest. Remember, the certainty equivalent approach is only just to reduce the cash flow. While the risk adjusted is to affect the interest rate. While the payback period is to look for the limits. The limits for us to pay back. We have seen non-probability average. And we saw the three methods being applied. And 3218, Abi. Good. And it's positive, Abi. We should invest, Abi. Therefore, the company or the firm should invest or should accept the what? Project. That is it. Any questions?
Yes, yes.
Why are we using different symbols to identify
Yes, that's what.
Sorry, let me just finish.
Okay.
The different symbols denote the discount factor for different problems. So, for example, if I'm looking at this discount factor, because this is 1 over 1 plus RF raised to power T.
Okay.
It's the same thing as 1 over 1 plus R raised to power
Normal,
T.
same thing, yes.
Yes.
We're just trying to say it's risk-free.
Kind of confusing.
It shouldn't be. But just know it's still R.
Yeah.
We only try, because we're looking at so many, we have done risk-adjusted projects. We want to make sure we represent with different items. But the idea is still rate. We now have MPV formula, Nabi. It's the R. But just the nomenclature, we does not change anything. It doesn't. Yes. After this certainty equivalent approach. Is it the question, are they? No, the summation is different. No. This is MPV, are they? This is MPV. This is our MPV stuff, formula, and this is our solution. For the certainty equivalent approach. Copy very fast. Let's see whether we can start the last one. No, we don't do that one there. Even if we don't solve it, we can do something. I agree. Okay, no problem. Let's digest this one. No one. Any questions, Sha?
No, let's go to the last one. I will still read all of them. You're tired.
No, don't worry. No what happened. I'll just tell you what. I'll send it. I'll see. So what I will do is
So you
that.
tell us what to do. How?
No word out. Mainly I set it up on the board. You know, if I set it up, I start the first one.
Okay.
If I fill the remaining 2, 3, becomes a kind of assignment until the next time we meet.
Then
Don't
it's
worry.
next week. Oh.
No, I said next time. Next week and the next time. Simple. But don't worry. Let's just put it there. It put me a more in the hurry than don't worry, let me.
They want to make sure, especially that certainty, equivalent stuff. Okay, I'll send that question. Okay, that one is called sensitivity approach. Now I mentioned that. That's sensitivity. It's still MPU. So it will take us time. And number 4 method. Abi? That's the last? Yes, that's the last. It's also the kind of presenting. Let's see. Those of us don't like, can I clean the board? The alpha means that's the symbol to represent certainty equivalent. The usefulness is to reduce this cash flow so that to make sure risk is taken away. Is that okay? They reduce risk by those ratios or kind of probability. They don't call it probability, it's certainty equivalent. Yes, we multiply that. This times this times this. See the board now, A times B. This A. So this one, it was given. And sometimes it can be calculated. It's in the question. It's in the question. It was given. It's there. It was given. And you can be asked to calculate it. I will tell you when that time is. When they say you calculate it, they will give you some factors to apply. If it's not given, then it's not certain. And at the same time, you should also read your book. So, what I'm saying is that why you should read your book? Some other time they could say define. I know definition is not much. There are more calculations. But you should also read your notes to answer some small questions like advantage of this or disadvantage of this. And you understand what I'm saying. But I don't know they carry calculation, carry small. So you need those graphs to add up. So you can't just, you still need to go and read. You can't just rely. So you can't just sit down and rely that we have done it. You won't read. You need to read. By the time you read, everything will work together. Number 4, I mean, the last one. Sensitivity. Analysis. Just a simple logic. If you look at the question that's in your group, yes, you know the question has Roman figure 1, 2, 3, and 4. Okay? I'll just take one, then we'll go for 2. Don't worry. These are the items we want to look at from the question. Yes, now. I've sent it. Don't waste time. Sharp. These are the items we want to look at. Initial cost, sales, production cost, our year. The initial cost is year 0. Sales in that question was given from year 1 to 6. Production cost is also from year 1 to 6. Our cash flow that will come out from all this, there is a cost, 750,000. Sales every year, 1.2 million. That's what is coming up on that question. Production cost, in anything cost is minus, Abby. Hello? Anything cost has a minus, Abby. Our cash flow that has payment is a minus. So because this production cost and this initial cost, anything cost is having a minus. So that one has gone. Discount factor, at how many percent there? Is it 16? Are you sure it's not 16? I could not see what I'm seeing.
I was looking at you.
The question you copy is 60%, have it? It's there. So there's initial cost. Did you see this 750,000 in the question? Hello, look at the question. Good. There was sales. The revenue that will be coming yearly. 1.2. Right with this. And when revenue is coming, there is a receipt.
Yes.
Will it have minus? No. Good. Then there's a production cost.
Yes.
Production cost, have it?
Yes.
When something has production, that is, we are making payment. And that's a minus. Is it settled?
Yes.
Right. The thing is no more hard. We quickly calculate our NPV. Go three. Oh yeah. The solution is 1 to 6. Have they forgotten? As we have been doing 1 to 6, 1 minus 1 plus R. This one is minus 6, Abi. All over R, Abi. Here's our formula. Have they forgotten? If you calculate, we don't have time. If you calculate, you should have something like this. Somebody can calculate that. The same thing is also 6. Somebody check out that. Multiply this, you have this. Are they checking? Oh, yeah.
So this one now is 1.2 times 3.68.
What do you have? What do you have?
Who is calculating?
Oh, God. And they say they want to go. Just calculate. Let's take, even if it's Roman figure 1, you can do the rest yourself. If the thing over, we'll come back to that. So for now, let's see what
this one is not.
It's the same.
Okay, so we did not do the
1
years.
to 6 now.
We did not do 1, 2, 3, 4, 5, 6, 7.
We'll just use this one last week. So this will be 0.16, I mean.
Yes.
0.16. 1.16 raised to power minus 6. For both, a line like that from 1 to 6. According to the question. Is it clear now? I have multiplied that 1.2 million times 3.684.
Who is calculating?
Okay. Confirm what I'm writing whether it's correct. Yeah, maybe. 3537 312. Our MPV. Help me confirm on that. Now 3 points, Abby.
Yes.
What I expect for is just 1.2 million times this.
Yes.
Already we know how to calculate this. We all know how to put our handles on the body. Oh, it's still on the box. You can still confirm that for your calculator. But we just need that to confirm it's 4421.
So.
Oh. I thought you have multiplied.
So now multiply 1.2 million.
Times 3 points. Time and the expect as I say so. So it's correct. 4. Correct. Second one, come. On the last one, 3.6847. 3.6847 times 96. Correct, Abi. Fine. Somebody add on this minus, Abi. This plus, this minus. So what do you have? You have plus, Abi. 134. Is it like this? Is it correct? So we have to go with this. Roman figure 1. What I
So did I ask the question?
Yes, Roman figure 1. Sensitivity margin of sales per annum. Very good. Sensitivity margin. We all know that margin means profit. No. Margin means profit. You don't know, you can check dictionary. Hello? Okay, nobody's there. So still imagine of what? Sales per annum. Is that okay? will be our MPV. What's our MPV on the board?
It's the MPV.
All over the present value of sales expressed as percentage. Who cannot do this? Who?
Correction. The MPV is 134328.
124.
328.
Okay, 124.
134328.
Okay, 328. Abby? Good. So sensitivity margin of sales per annum will be the MPV that we know on the board. 1342328 all over present value of sales is 4,21640 times what? 100 over what? 1.
Somebody press calculator.
Oh yeah.
With that, this is the sensitivity as per sales. The rest will come some other time. We have gone, yes, we have gone more than 2 hours there. But let's say,
Help me. Somebody now. Which one has said?
press calculator and this divided by this
Times 100. 3%. Simple. Now 3 what? Just 3%.
So what it simply means is that
Our sales, the conclusion is that our sales must not be reduced, by more than 3%. What it simply means that if our sales goes down, we're not going to break it. We're not going to make it. Is that okay?
It just goes down small.
More than 3%.
Okay.
If it goes
If it goes
2%, we can't break it. And it's not going to be a good project to invest in. That's what that sensitivity. The sensitive that you should not toil, should not go beyond something. If you go lower, there'll be a crash. It is sensitive. Just to some of us.
Sorry, if it's 2%, you are still okay.
The question is saying that it should not go more than. It's more than. So if it's more, it's an issue. 5, well, for 2.5 is manageable. 2 is manageable. But that does not mean to go to 5, 6, to go to that. We cannot break even. And such contract or business or project cannot be properly. We'll stop here at Roman figure 1. At least we have told you what is sensitivity, at least you have idea. And what it simply means that we have at least dealt with capital projects under certainty. We have dealt with capital project under uncertainty. We have dealt with mathematics of finance. We have dealt with overview of what finance is all about. And by His grace, next time, we'll continue with more questions and more interesting.